Can you hear me all the way to the back? Yes? Okay, good. So I'm Dafna, and about a year ago I ran into Bob Mankoff, who's the cartoon editor of The New Yorker. And he happened to mention that he has a data set of cartoons. Now, I was immediately intrigued by this data set as a computer scientist, because the thing is, you know how humor is always depicted as a distinctively human trait? How you have movies and science fiction and robots and computers can do anything on Earth, but when it gets to telling a joke or understanding a joke, it looks like this. So I was really curious to see what I could do with this data set. Now, you might ask me, what does KDD have to do with humor? And I'm going to argue that humor is actually a really important dimension of digital content that's usually overlooked, and has plenty of applications that are super related to KDD. Now, instead of going through all this list, let me just tell you about my favorite two applications. Okay, first application. On April Fool's Day, Tesla had a press release where they said they're going to release a smartwatch. Now, this was clearly a joke, okay? If you read the press release, it said stuff like, not only will it show you the time, it will show you the date. Or, it can work in different countries, our watch. So it was clearly a joke. But algo trading did not catch on the joke, and the price of the Tesla stock just surged. Okay, so lots of people lost lots of money because their algorithms could not figure out that this was a joke. Second application, you might remember a while ago, Facebook was saying that it's going to test a satire tag because people just could not figure out that The Onion is not a real newspaper. Okay, so it'd be nice if you could do those things automatically. Okay, good. So this is why I think you should care about humor. Let me tell you about what we actually did. So how many of you know the New Yorker cartoon caption contest? Oh, more than I expected. Okay, so the New Yorker publishes a cartoon without a caption, and they invite readers to submit their ideas of, a funny caption for this. And they usually get something like 5,000 submissions, and then there's a poor intern that has to read through those 5,000 submissions and pick the funny ones. Now, I talked to that intern, okay? He describes his job as a soul-crashing. He said that after reading 200 things, nothing is funny anymore, he just wants to crawl up and die somewhere. So I was listening to him and saying, well, okay, so do you think I can help? Or more concretely, can I come up with an algorithm that will rank those 5,000 captions from funny to less funny? Okay, motivation clear? Good. So how do we do this? Again, the goal is to rank those 5,000 captions from funny to less funny. Now, if you think about it, there are many reasons why one caption can be funnier than another, and the biggest one is just they're telling completely different jokes. So as a first step, I decided to focus on captions that hinge on the same joke. Okay, so two people came up with a similar joke idea, just phrased it differently. And I wanted to see how the linguistic effects change how funny the caption is. So let me give you an example. This is one of my favorite cartoons. It's this car dealership, and there's a salesperson that tries to convince this poor couple to get into this creature that's part card, part animal or monster. Now, upon saying this, one of the readers submitted the caption, "It's a hybrid." Okay, reasonably funny, reasonably clever. Now, did I say one reader? It was actually plenty of people who looked at this and say, oh, hybrid. And actually, out of the 5,000 submissions, we had 1,100 versions of it's a hybrid. Okay, so, and it's more common than you may think. If you look at this graph, there are quite a few clusters of jokes that are in the hundreds. Okay, so what is it? It runs on roadkill, listen to this baby purr, that kind of things. So people are not as original as they would like to think, I guess. Anyway, we use those clusters to find pairs of captions that hinge on the same joke. And then we use it to construct a data set. Okay, so we had 16 cartoons, and we went to Mechanical Turk and showed people captions and asked them, so, hey, which one is funnier? And we collected statistics. Now, throughout this entire project, we collected something like 100,000 judgments that boiled down to about 5,000 captions on which we had wide agreement, meaning at least 5 people ranked, at least 80% agreed. Okay, so 5,000 pairs of captions on which I have a reasonable reason to say, well, I think A is funnier than B. Next thing, we took those captions, we extracted tons and tons of linguistic features. Okay, the length, polarity, or sentiment, the location of the joke, do we say hybrid at the beginning or at the end, readability metrics, perplexity, parts of speech, all around the place. Next thing we did was just analyze those features. So which feature is actually important when you want to distinguish between funny and less funny? And I'm just going to give you the high-level message. If you want all the beautiful statistics, p-values, Bonferroni, everything, it's in the paper. But I just want to give you the bottom line. So bottom line, if you want to write a funny joke, funnier captions are simpler on pretty much every aspect, okay? Lexically, syntactically, ease of reading. And not surprisingly, it pays to keep the joke to the end. Okay? There's a reason they call it a punchline. What was a bit surprising was that most humor research I read said that humor correlates with negativity. But Mechanical Turk people actually seem to prefer the positive ones. So I still need to look into this. I suspect it has something to do with the sentiment analysis tools that we use, missing on stuff like sarcasm, but I'll get back to this point at the end. Okay, so this is single features, but obviously single features are not enough, right? You actually need to combine all those signals. And what you really wanted to do is learn a classifier to be able to do this prediction task of here are two captions, which one do you think is funnier? And we had a random forest classifier that achieved something like 70% accuracy. And I just want to stress out that the idea was you test it on cartoons and captions that it is not seen before. Okay, so subset of cartoons for testing, subset of cartoon for training, just to see how well it generalizes. Okay, breeze in, breeze out. This was for captions hinging on the same joke. Now let's move into the more interesting part of comparing any captions, any joke. Now most of my features I talked about, length, sentiment, they stay the same. But there are two main differences that I'd like to highlight. First is that, remember, joke location was an important feature, and now we no longer know where the joke is. Because earlier you could say, well, this came from the hybrid cluster, where do they say the word hybrid? But now it can be anything. So what we decided to do was say that the joke phrase is the phrase with the lowest perplexity. Meaning you start reading the sentence, okay? It gets 25 miles per. And your language model is screaming at you, gallon, gallon. It needs to be a gallon, maybe later, but gallon. And then you see rabbit. And you did not see this rabbit coming, okay? It has very, very low probability. So we said this would be the joke. And you can see some more examples here. This is our Paleo model. And I'd actually like to point out at the very end, see, and the guess mileage is incredible, where the algorithm saw there was just no joke there, which makes sense, right? Because it's a perfectly reasonable sentence in a car dealership. It's only funny because it's a normal sentence in an abnormal situation. Okay, good. This was the first difference. Second difference. Well, I said that I don't think even people would be able to do this prediction task of which caption is funnier if I don't let them see the cartoon. So the algorithm also has to take the cartoon into account. Okay, so let me tell you how. So most New Yorker cartoons seem to have this background context. There's a car dealership, a salesperson, and then there's something anomalous about the image. In this case, the car has animal legs. And I wanted to see how the caption tried to bridge those normal and anomalous parts. Okay, so you look at captions like it gets 25 miles per goat. Okay, so miles makes sense in the car dealership context, and goat makes sense in the animal legs context. So what I did was just measure word-to-vec distances from the caption terms to the normal and to abnormal. Let me give you another example. Okay, another cartoon. It has an office and this weird staircase into the cloud. So we had each cartoon manually tagged with us to list the context and the anomaly. You can see here office workspace versus stairway in the sky. And again, it's word-to-vec, so I don't care about the exact words that I choose. Also, you need to do it just once per cartoon, not once per caption, so it scales nicely and everything is good. Okay, remember this cartoon? Good. So I plotted some of the captions on, this similarity to context versus similarity to anomalous parts. And for example, here you see, I'm sorry he just stepped out of the office. Okay, perfectly normal office sentence. Now, in the exact opposite corner, you see, yes, you really can buy a stairway to heaven. So a caption that really, really focuses on the abnormal part of the image. Now, the nice thing about this plot is that when you get closer to the diagonal, you see all the word plays coming in. Like here, our technician is addressing a problem with a cloud. Or the CEO just took the golden parachute package, or climbing the corporate ladders. So you see lots and lots of structure emerging. Okay, those are the major two differences. Let me tell you what we learned. Again, if you want to submit your own entry or something like this. So first thing, you want to use really simple grammar, but surprising words. Okay, again, it gets 35 miles per goat. Super simple grammar, but you don't see this goat coming. Another thing, proper nouns can completely and totally kill a joke. So this one, oh my God, Florence Ziegfeld has gone to heaven. Okay, how many of you know who Florence Ziegfeld was? Okay, yeah, oh, okay, good. So I actually had to look him up, and I still don't think this joke is funny. There's one caveat to what I said about named entities. Is sometimes they're actually funny, like when somebody makes fun of the NSA and it has all those baggage on top of it and privacy. So you still need to let the algorithm know which named entities have connotations with them and which are just completely obscure. But in general, don't use named entities. Horrible, horrible idea. Okay, what else? Like before, you want to present the joke as close to the end as you can. You really, really want to bridge the normal and the abnormal part of the cartoon. And do you remember I was worried about sentiment earlier? So now it's no longer significant. I mean, if anything, there's a slight tendency towards negative, but not significant. I didn't actually say anything right now. Okay, and like before, we had a prediction task, and we got 64% accuracy, which makes sense because it's a harder task. Now, you might look at the 64% and say, well, okay, there was definitely some signal there, but it's not a very impressive signal. But you need to remember that my goal is not to build a classifier, okay? My high-level goal was to save the poor intern. So what I really, really wanted to say was, well, now that I know how to compare two captions and I get some signal, can I actually rank everything for him? Okay, can I just find the funniest one? So what we ended up doing was holding a tournament where all captions were paired against each other. Again, it's what's called a Swiss system tournament. You can think of it as a chess tournament where if you've lost, you're not being kicked out. You're just playing the next level against somebody who's roughly your level. Okay, so all captions playing against each other, and this results in a ranking. Now let me give you an example. So this is for the car cartoon. These are some of the top ranked things according to the algorithm. Okay, so just listen to this baby purr. And it won't cost you arm and a leg. Best not to kick the tires. That's one of my favorites. Just don't ask for leather, and you'll save thousands on tires. Okay, these are the good ones. Now, at the very bottom of the ranking, we had stuff like, the previous owner played Frisbee. This is the mortar package. A stupid pun about GMM. A stupid pun about passing gas. Okay, now the last one here, for the life of me, I do not understand this one. Okay, Bob and I actually sent an email to the guy asking for clarifications. He did not reply. If anybody understands this, please come talk to me later. This is actually driving me nuts. Okay? Anyway, this is a reality check, but you still need to really evaluate it. So what did we do? So for each cartoon, we had manually selected. The New York editors picked the top 10 captions out of those 5,000. And the question is, well, suppose you start reading the ranking from top to end. How far down the list do you need to go to be reasonably sure that you actually found all those top 10? Okay, so how much workload can I save, basically? Okay, just go down the list, find the top 10. So on average, all of the top 10 appeared in a 56%, the top 56%, which means we cut about half of his workload. Now, there was a very nice trade-off. So if you're okay with finding just the top 8, you could stop reading a lot earlier. If you're okay with finding the top 5, you can stop reading way, way earlier. And what was even nicer is that if you don't care about the exact one, but you just want to find a super close match, then he could basically stop reading after the first few hundreds, which probably means I should combine this with clustering. Okay, so instead of just ranking all jokes, cluster them first and then rank. But anyway, we showed this to the intern. He was very, very happy. Conclusions. So the point of this was to take the New Yorker cartoon contest and take those 5,000 submissions and rank them according to how funny they are. And we showed how we can, using relatively simple tools, reduce the workload on the judges. Now, I want to stress out that those results are preliminary, but I think they're promising. Because when I started this project, I was really, really worried about whether there's going to be any signal there. Okay, because it's super short ones, and I don't use any natural language understanding or common sense reasoning or even like very deep image analysis. So I was worried there's not going to be anything there, and I think this is promising. Okay, more exciting stuff. We're actually releasing the dataset. I mean, when the lawyers stop talking to each other, but it seems like it's actually happening, and we're going to have a dataset out there so everybody can play with this. Awesome, awesome things. Okay, future directions. So this is mostly about humor recognition, but I'm actually really curious about humor generation. Can you use this to tell a joke or to help people come up with better jokes? There's some interesting aspects of personalization or cultural effects. And one of the things I was wondering about was whether the Mechanical Turk people have the same taste as the New Yorker people. But again, if I use Mechanical Turk in the US, what about if I used it in India? Okay, there are plenty applications, like I said at the beginning, especially in the way we interact with computers or we interact with each other through computers. And the holy grail is that at the end, if computer science or data mining actually decide to take a stab at humor, then we might learn something about it in the process or get some insight into human cognition. Or at least that's my holy grail. So that's about it, I guess. Thanks.
Captions.
Yes.
I have a question. I have an answer, not a question.
You have an answer.
2015 times 7 is 14105. It's in dog years. That's the joke.
Oh.
I know. Yeah.
Oh. You're awesome. Wow. I'm so glad I came here. But yes.
Thanks. When I saw it, I thought four-leg drive or something like that. So I guess my question is, while you've got the whole cartoon, you've got some subparts of the cartoon, and using like a system of systems approach, you could actually break the cartoon down into the subsequent subsets and then name and get your different comedies on that. So I guess, are you always just looking at the visual image as a holistic, or are you actually considering breaking it down into its subparts as well?
So when I ask people to tag the cartoon, I basically ask them to tag the parts of it. Like there's an office, a secretary, a phone, and I ask them to break it into two lists, like what's normal and what's abnormal. Okay, so there's an office, and the abnormal stuff is there's a duck giving a PowerPoint presentation. So I do get little bits of the image. I don't have any spatial thing. Like I don't know where they are located, and we're looking into doing stuff like gaze tracking, but so far it seems to be working fine.
One thought: if you're using mechanical Turk, not only ask which is funnier, but please write a short description of why.
Oh, we did this actually. I didn't talk about it, but yes, we definitely did this. And by the way, I'm always surprised when I use Mechanical Turk about how you add an optional box and people will write like paragraphs and paragraphs analyzing themselves to death. But one of the things I saw is, I read at some point an article by somebody who won the New Yorker cartoon caption who was saying how you need to do this and never ever use puns because puns are from Mad Magazine. You need to use something much clever. And the Mechanical Turk people are like, oh, there's a pun. It's funny. There's a pun. There's a wordplay. So I have a very nice tag cloud into why people prefer certain captions. But if you have any idea what you want to do with the dataset, come talk to me. I really don't like the lights here, by the way. Yes.
One more question.
Okay, well, thanks.